Our third presenter is Michael Schade, right? So Michael is a software engineer at the Center for Advanced Transportation Technology, known as the CATT lab at University of Maryland, where he built tools for traffic engineers and researchers to study and visualize traffic data. In his spare time, he runs the Transportation Techies Meetup group in DC. That's pretty cool. So Michael's going to talk about vehicle trajectories for improving planning and operation.
Yes, I see the timer. Where is the plus button? I'll figure it out. Oh, that big green thing. Okay. Hello. It's so exciting. What a privilege to be here at the National Academy of Sciences. So I'm here to talk to you about a product that we've invented at the CATT lab, that's the Center for Advanced Transportation Technology, over at the University of Maryland. Let's see if the screen button works. Oh, hey, there it is. So you can see our lovely offices there. We do have super cool lighting, as you can tell. Three of our most famous products, I hope you all have heard of them, and I hope you all are daily users of them. VIZ, how many people here use VIZ? Who didn't raise their hands? Okay, if you didn't raise your hands, talk to Michael Pack. He's over in the back row there. Try it, you'll love it. PDA, that's the Probe Data Analytics Suite. The main difference is VIZ is for checking the live data. PDA is for checking all of the historic data. And then how many people here even know about trafficview.org? Wow, okay, so you do now, so you can all raise your hands the next time they ask you that question. So this is basically the free version of VIZ, and it actually gets a lot of use here because you don't have to sign up for it. So the other tools, usually like your agency will sign up, and then everyone who's a member of that agency or a contractor who works with them gets access to all the data. So VIZ, it's amazing. They collect sources from just about every traffic-related data source you can imagine. The only number I have here on this is the probe data. Our data people tell me we get, this sounds like a lie, but it's true, we get 2.2 million records a minute. And we don't just like look at it and throw it out, we actually record it. So that's what makes this such a powerful tool for looking at historical data. So if you're a researcher and you're trying to study the impact of maybe a storm that you had one year and you want to see how did that affect traffic flows, or maybe you invested in a bridge and you want to see, well, how did this actually change travel patterns and stuff? Was it worth the money that we spent on this? You know, so if you're trying to look at how things have changed throughout the time that you've been working on your project, this is the tool to use. So you can see all the different sources of data that we ingest, all the different purposes that we try to show and reveal to you. So basically, like if you're a researcher or if you're in operations, this is a great, great tool for you to use. So now, but I don't actually work on that. So one of the types of data that we don't have there is the trajectory data. So normally we're measuring like on a specific road segment, a TMC, what's happening on this TMC, what's happening at this intersection. But now what people want to do is they want to study how do people actually travel around here. Traditionally, this has always been done with survey data, which is a very tedious process to get and to collect, and it's also very expensive to get. Now with the proliferation of GPS devices, and the people who are aggregating this data, we now have a huge, huge resource that's available to us to study how people move around. So trajectory data, this is basically we collected it's one trip at a time. So you can see here, for instance, your GPS device would be sending out little pings as you travel along your route, so we know where you start. Of course, we have the timestamp for that. We know when you arrive. You can calculate, of course, now, based on that information, the speed as you travel along. You can also calculate the route that people take. That's the most valuable part of all. Yeah, and so I think, let's see, that's next one. So here's, has anyone already seen us earlier today in someone else's slide deck? All right, whatever. How cool is it? So let's just talk about the GPS data itself. So some of the stuff that you can learn from here, like we have the background map that shows the roads, but you can imagine if we just had a black background, you could actually use this GPS trajectory data to figure out where are my roads? What are the main roads, right? What's the biggest road in your town? Well, look at this. You can see where the heart of the traffic is. You can also now surmise relative speeds. Where are people traveling the fastest? Where are your bottlenecks? So it's just kind of a great way to view your data here. So this is our tool. We call it Trip Analytics. When you get there, so we currently have 4 data sets. But obviously this can grow. So like anyone who's interested in using this tool, you can provide to us the data that you use or work with us to figure it out. And we can just add it as another selection here. So you can see the variety of data sets we have currently. The Maryland one is by far the largest, and it's the one that's actually still growing. It's like every few months we still just add the new sets of data. And you can just sort of see the scale of what we're talking about. Like that's 192 million trips. And what I'm not counting there is, again, so the data that we're storing is there's obviously one record for every trip. Well, each of those red pings is its own record. So you now multiply that times how many pings do you have in a trip? It could be 100, it could be 1,000, it could be much, much more. So this data grows into a monster. And so the goal of the tool is to make it easy for people to investigate the data without having to pour through millions and millions of records on your own. So here's like a sample view of when you inspect a data set visually. So for instance, with the Maryland data set, what we mean by Maryland is we're actually talking about anyone who travels through the state of Maryland. So if you are taking a trip from Florida to visit your grandmother in Baltimore, that is now part of the data set. So you can see there are in fact people who are traveling into the heart of Maryland from across the eastern coast. And actually, we probably have some stray people. There's always one trip, and you're like, who is that person? You know, like, who makes this trip? That's 24 hours, makes no sense, but they're there. And I also have to say, so when you talk about the GPS data, there's so many challenges, and I think you brought up a lot of these same points. You know, challenge number one is the raw data, of course, is just the latitude and the longitude, and it's not aware of the road network. So challenge number one is what we call snapping, rhymes with mapping, same thing, snapping your GPS points onto a road network. Then there's the challenge of, well, just because the person's driving on a road, does that route actually make sense? So for instance, we might try to have the device ping, let's say every second, every 10 seconds. You know, you will lose the signal some points. And so if you have someone who's doing a trip here and then they miraculously teleport someplace else like 2 minutes later, you might have a good idea of how they got between those 2 points, but now can you algorithmically calculate that? So that's one of the challenges that we have to do with that. So that's what that's talking about. So you can see like the points that are not quite on a road. So we want to, in order for that to make sense, and in order to talk about it from a road perspective, you have to snap it to the actual road network. So these are the sort of challenges that we have. These are some of the uses that we think you out there in the departments of transportation and all the research places might be interested in. So these are some of the things that we're looking at, some of the problems we're trying to solve through our application. Okay, so this is what we have so far. So there are 3 different tools. So each tool is a different way of visualizing this information. So I'm going to go through all 3 of those. The first one, OD matrix. So what you're selecting here is, first of all, your jurisdiction. So OD is, of course, origin destination. So what you're doing is you're saying, well, I'm interested in people whose trip started in this set of locations and who travel to this set of destinations, okay? So in some cases, you might say like, well, everyone in Maryland, everyone in PG County. So in that case, your origins might be the same as your destinations, but they don't have to be. You could say, I want to see everyone who traveled from Baltimore City to the county of Baltimore, or everyone between Baltimore and Washington, et cetera, you can imagine. So here's a tool for, you can just select it. You can see we have 3 different resolutions. So that's the type of jurisdiction that you're selecting, the county, the sub-county, or the TAZ. How many people even know what a TAZ is? Is that common? Okay, actually, I want to sympathize with the people who had no idea what that was, because I am among you here. I still struggle with, it's Transportation Analysis Zone. Did I get that right? Is that common? Everyone uses it? Not everyone, who knows? So I'm learning about TAZs. And in fact, one of the things I learned is that there are different versions of TAZs out there. So the TAZs that we initially populated this with came from the US Census Bureau. Anyone here from the US Census Bureau? Yeah. All right, because I need to talk to you. Okay, but some of the other people, like you might have your own definitions that you're interested in. Or maybe your planning department says, we actually want to study it and draw our own borders for what we want to study. So that's possible too. And in fact, 2 of our data sets have already done that with their custom TAZs. And of course, you can select the time periods. They don't have to be contiguous. You can do it by day of week, so if you're interested in weekend traffic. There's also a filter for what type of vehicles you're interested in. So we're not, at this point, we don't have any demographic data. So I think a lot of the surveys were saying, like, who are you? And also, like, why are you traveling? We don't yet have that, but that's possible in the future we'll have that. But we do capture the type of vehicle, so you can make some guesses about that. With the, what is it called, the light, medium, and heavy. So I know this, I think the name of this session has the word freight in it. So I think my only point about freight is that the heavy vehicles are presumably the freight, correct? And the light ones are presumably the passenger vehicles, unless you have a very large family, I guess. And you transport them in an 18-wheeler. I think there's a movie in that. And then this is the result that you would get. We can see a closer view. What happened to the closer view? Oh, you know what? I'm sorry. Can you go back? Is there someone manning this? Uh-oh. Oops. This is a movie. I forgot that. So I don't know if this will actually play. There's no one there who can hit play? Okay, so we'll save that for the end. That's okay. I can still talk about it because I've got a screenshot here. Yeah, we're okay, because I can just talk about it from this screenshot. So this is an example where I picked the origins and the destinations to be the same. In this case, it is counties within Maryland. Does anyone notice a pattern here? Like if you squint, you don't even read the data. I think the most obvious thing that you'll see is the... Oh, yeah. You actually gave the answer. Yeah, all right. I don't have a prize, but you win, whoever you are. So what you see immediately, of course, is the diagonal line, right? And that's because we have the same array in the same order of origins and destinations. So what does that tell you? The fact that this is the darkest, so the darkest value, by the way, you can select that. There's a threshold for how you want to color the values, the cells based on the value inside them. So the darkest values have the highest number, so you don't have to squint to see what the numbers are. But what this is telling you is that everything that's on that diagonal is one county to itself, right? So that kind of makes sense. If you're looking for traffic within Maryland, most people aren't going to make their daily trips between 2 different counties. It does happen, certainly with Baltimore and Baltimore County, its surrounding jurisdiction. But it's kind of nice for me because I can't verify the data by saying, oh, right, 11,292, that's exactly right. But I can verify it by looking at this and saying, oh, it makes sense. This is the pattern that I would expect to see. You can also do things here with some additional changes here. You can say, I was only interested in arriving trips during this time period or departing. You can change it to be the raw number, or you can change it to be a percentage of all the trips that you had filtered already. And you can also narrow down. Sometimes if you're studying TAZs, there might be hundreds and hundreds. It's hard to kind of make a judgment call on a matrix that has too much data. So there's a way that you can filter this down to make it smaller and easier to read. And apparently, a lot of the people who've used this, one of the features that they like the best is the ability to export raw data. So you can do that as well. And like I said, the raw data for this, it's actually 2 files. The first file where you have 1 row for every trip, which summarizes it, and it has the origin and the destination. And if you want the raw data, now each of those rows will have its own list of rows linked together by an ID. So again, that's massive. So this is actually the same data that we were just looking at. It's just displayed differently. Instead of a matrix, this is a chord diagram. And I'm going to ask you the same question. Without looking at the numbers, can you make any sort of judgments about what the data is telling you just by looking at this beautiful but kind of complicated drawing? It's actually the same conclusion, right? So the idea here is, again, this works only because the origins and destinations are the same. So those are the exterior of the circle here. Every trip between 2 of them is the chord or the arc that goes between them. And in fact, the ones that actually travel between the counties are the narrow, narrow, narrow bands. And the giant arcs are the ones that just go back on itself. So again, visually, you're seeing here, aha, this kind of makes sense. Most counties, the people who start in one county end up in the same county. So, but it's much more beautiful than the matrix. It can be a little challenging to make sense of, though, I think. And we also kind of summarize up here, like if you're interested in just what are our top OD pairs, now you can just instantly get the answer, whatever that says in blue, Montgomery to, again, Montgomery County. So our next tool here is called segment analysis. So now what we're doing, the point of this one is you tell us which road you're interested in, and then we'll tell you what the origins and destinations are for the people who traveled across that road. So in this case, I selected I-270, wait, did I? Does it say I-270? Yes. The I-270 spur is the same sort of query parameters that we saw before. You give us like a way to narrow down the date range, so the dates that you're interested in, and the type of vehicles, of course. And what you're seeing here, there's two colors. One is, it's colored by orange if it's predominantly the origin data, and blue if it's predominantly a destination. So this kind of makes sense. When I selected 270, and you can barely see it, if you can pick where DC is, there's a little green segment above it. And I selected southbound. So it kind of makes sense. Again, like I need to look at the information and say, oh, this actually makes sense, correct? So it makes sense that if I'm asking for people who went southbound, the origins would be generally north of this road segment, and the destinations would generally be south. So it kind of makes sense. And I think, yes, so this is a zoom in here. So again, this also makes sense. So now I'm showing the actual numbers here, right? So there's the road segment that I selected. The number there is that 253,000, and that's just of the people in my data set, right? So you can also view it as a percent, so you kind of know for everyone who's already been selected, how heavy is that? But you can tell just by the color that this is the dominant county here. This is where most of our origins are. And again, you can kind of see the numbers here too. So this time we're looking at not just origins and destinations, but we're saying, show me only the numbers for origins. That's why the areas that are south of my selected road are also in orange. But you can see clearly, if you can't read the numbers, like it's 125 out there in whatever Belhaven is, and then 3,800 a little bit to the north. So again, it's just kind of nice to verify that the numbers make sense when I do a query. Oh, hey, this movie is working. Okay, well, let's watch a movie. So this is the user. They start at the beginning. They're selecting segment analysis. They're going to enter the road that they're interested in, and everyone loves 270. It's a very interesting road. So the first thing it does is it will draw this, it'll draw the selected road segment. And Michael, I only have 3 minutes, so let's just go forward. We can show you that later. So the last tool, of course, this is the most exciting one. This is what I'm working on right now, route analysis. So before in segment analysis, we selected a road. Now we're going to select the origin and the destination visually on a map. And what it's going to tell us in return is which routes did people use to travel between the two. So it's kind of, in a way, the companion piece to the other tool. And so not only is it going to draw for you, so like the table here is showing us what the top 3 routes are between the origin, destination. I'm sorry. I think, is it intentional that origin is colored orange? I just realized that. Destination, what's a brown color that starts with, color that starts with D? Dusty. I don't know, whatever. So the purple, blue area, of course, is our destination. It's showing us now the top 3 routes that people took to travel between those two. What we're also now seeing is you can also look at the same data, but in a variety of bar charts or just other data visualizations that we have. There's also the ability now to compare 2 different time periods. So again, if you're interested in the impact of an event, be it some sort of weather event or some man-made event like the introduction of a new bridge or the closing temporarily of a major highway, people want to study, well, what happens when we close this bridge, when we open this bridge? How did that affect the flow of traffic? This is going to be your tool for studying that information. Different charts that we have here. Oh, that's the end. Oh, so sad. So anyway, so thank you for letting me share this information with you. I look forward to hearing from you. This is my email over here. That's my personal Twitter, which I think is great. And as Pat mentioned, I do run the Transportation Techies Meetup Group, and that's actually, Techies DC is the Twitter handle for that. If anyone's in the DC area and interested in how coders build tools for transportation stuff, that's for you. So thank you very much for letting me present this to you.
Questions?
Thank you. Oh, there is time.
Hi. How do you do any sensitivity analysis in terms of how you define a trip, in terms of the data if the person is stopped at X point and how long?
We talk about that a lot. So that's a question. So our data sets are not dynamic, so they're already provided to us. So that's actually a question for the step before I get to it with our tool. And it varies per data set. You know, obviously people want to say, well, if you stop for gas and then continue on your way, that's obviously still the same trip. But what happens if you go to a hotel and you stay overnight? That's kind of a question for you when you kind of when you're working with your partner. So for like these 4 data sets that we have happen to have come from INRIX. We are data agnostic, so if you get data from anyone else, you have the freedom to make that decision yourself, and we'll just, you know, consume it and then share it. Yes?
Hey, who did the colors
Who did the colors?
on your maps,
On my what?
on your visualization?
The colors. Well, we have a wonderful art team. So they tell me the hex codes to use.
Her name?
You're talking about the orange and the blue?
I believe the person who did that took my class.
Oh, you're talking the actual person, Jenny Lees? Yes, she's our wonderful art person.
Tell her she took my class at the University of Maryland. Tell her she did a very good job, okay?
I will indeed. Yes, she does in fact do a wonderful job.
Seriously, she took my class in the spring at the University of Maryland. I spotted it. Anyway, thank you. Tell her she did a good job.
Thank you. Yes, she does. She definitely does do a good job. We just had a meeting yesterday. So our design team, they not only pick the colors, their job is also to work on all of the user elements, the interfaces, to let us know what's best for the user to communicate with us, what they're actually looking for.
Yes, I should say that the CATT lab attended there's a human and computer interaction symposium that the University of Maryland hosts every year.
Well, they're very famous for that, aren't they?
Yes, and Michael sent some of his people, and they attended my color tutorial, and I recognize this.
All right, well, hopefully I can go next time. Thank you. Yeah, the human-computer interaction lab, I think they're famous for, I forget the specific example, but it's one nice part about working at the University of Maryland is we have a lot of other great teams on campus that we interact with and that we learn from. So hopefully just all is a process of making our tools better and better. So thank you for being a part of that and contributing. Anyone else? Yes?
I get a question for the core diagram that you showed.
Oh boy.
Flow. It's related to the color that you choose or your team choose to. I'm just curious because I found it hard to present flow information with what kind of colors to choose and, you know, in what order you want to put your counties, for example. So I'm just wanted to hear your take on that and whether or not you have any like experience or lessons learned about that.
I do have thoughts. So let me first clarify, for the core diagram, that was me going rogue. So I showed that to Jenny after I did it.
I was talking about the end, the last one.
Yeah. He's talking about the core diagram, which is, in this particular case, it happened to be a rainbow design. So that's me just mathematically saying, as I move around, I have like 22 counties. I'm just going to divide the 360 degrees of the color circle, you know, into 22 different segments. That's what I did there. It's a little more complicated. We didn't have an example, but it's possible that you could have picked, you know, 4 counties in Maryland and 10 in Virginia. And so in that case, to highlight that you're not just looking at a variety of counties, but you're looking at 2 different states, there's actually now calculated to be a larger jump between the state border. Yeah. And it is, the core diagram is notoriously difficult to follow. That's why I was trying to kind of analyze it just from stepping back without getting into the weeds too much. But if you were to look at the actual tool, there is, of course, the ability. You hover over it, and it will identify for you what exactly you're looking at. And in fact, if you've discovered one of the top 10 OD pairs, it'll kind of highlight, oh, you're on that number 1 pair. You're looking at it right now. Yeah.
Do the colors mean something?
They don't. The color was just used as a way to divide up, to
So-
distinguish between counties.
So there's a tool called Color Brewer.
I've heard someone mention that today.
Cynthia Brewer has a category, it's called categorical color. And there's some selections, and you might want to try them.
Yeah.
That way you wouldn't have the rainbow confusion that he's talking about.
That's a phrase. Is that a phrase, rainbow confusion?
No, it's one of the most common, I'll cover it tomorrow. It's one of the most common difficulties in visualization is to do, especially scientific and information visualization, using the rainbow color map. The gentleman just described one of the common confusions.
Yeah.
But if you don't have a reason to have it, you
Right.
could use Brewer's categorical color maps.
Yeah. Again, the color wasn't conveying information in that. It was,
Offer tomorrow.
yeah. The color was just being used to distinguish between the 22 different selections. That was it. Anything else?
Any
All
other
right. Thank you so much for the feedback.
Great.